Hello, everybody. We are back with another visual pattern challenge. So here is step 1 of our pattern. Here's step 2. Here's step 3. And your challenge is to predict the number of squares in step 4. If you can do that, can you also predict the number of squares in step 43? And could you write an equation that would be used to predict the number of squares in any step at all? So that's the challenge. If you'd like to accept that, pause the video and see how you do. All right, so it looks to me like this pattern is growing pretty quickly, and it looks like it's growing in two directions, right? It goes up a little bit and it goes out each step. So then let's see. It starts at 3 by 1 here, and then it goes up 1 and out 1 and up 1 and out 1. So this is 1 by 3, and this is 2 by 4, and this is 3 by 5. So I'm guessing just add 1 to each of those for step 4, we'd get 4 by 6. So there should be 24 in step 4. That'd be my prediction. And also, I'm going to predict that this is not a linear pattern. When it's growing in 2 dimensions at the same time, that seems to suggest it would be a quadratic pattern, an x squared in there. So let's analyze the numbers and see if that hunch is correct. So I'm going to list the step number and the number of squares. So in step 1, we've got 3. In step 2, we've got 8. In step 3, we've got 15. And in step 4, we're saying 24. And then we can find the differences here. 8 minus 3 is 5. And 15 minus 8 is 7. And 24 minus 15 is 9. So this is not a constant, so it's not linear. That part of our hunch is correct. Let's take the difference of the differences. 7 minus 5 is 2. 9 minus 7 is 2. Aha. When we get a constant in the second order differences, in the difference of the differences, we know it's an x squared in that equation somewhere. So this is a quadratic pattern. And I think a good way to approach figuring out what the actual equation is to block out an x squared in each step. So there's an x squared, 1 squared. And x here, of course, stands for the step number. So in step 1, we have 1 squared. In step 2, we have 2 squared. So that's this chunk right here. And in step 3, we have 3 squared. And then ask ourselves what's left over. Well, we have 2, and then we have 4 blocks left over, and then we have 6 blocks left over. So it looks like it's the step number, but 2 of them, right? There are 2 1s here, there are 2 2s here, there are 2 3s here. So that's really a 2x, 2 times x. The step number is x, so I would just add 2x to our x squared. So each part is x squared plus 2x's, x squared plus 2x's, x squared plus 2x's, like that. So I think we can be pretty confident our equation is y equals x squared plus 2x. But let's just plug in the numbers and test it to be absolutely sure. So we'd have y equals 1 squared in step 1 plus 2 times 1. That would be 1 plus 2 is 3. Good. Y equals 2 squared plus 2 times step number 2. And we'd have 4 plus 4, and that is 8. That's what we've got. In the third step, y equals 3 squared plus 2 times 3. So that's 9 plus 6. That is 15. Yeah, looks like this is working out. So if we're confident in our equation, we can use that to calculate the number in step 43 pretty easily. We just put in 43 for the step number. So y equals 43 squared plus 2 times 43. And 43 squared is 1,849. And then we've got 2 times 43, that's another 86. And so what is that? 1,935, I think. So how did that go for you? Did you get 24 in step 4? Did you get 1,935 in step 43? Let me know. Thanks, everybody.